Hello students, welcome to this lecture, One Probability. So in this lecture, we will discuss NCERT exercise 14.2, question number 11 to 21. So in our previous lecture, we have discussed NCERT exercise 14.2, question number 1 to 10. Okay, so we will discuss now question number 11 to 21. So this is disclaimer. So we will cover NCERT exercise 14.2, question number 11 to 21. So students, first of all, make sure you have with your notebooks and pens ready. So read the question very carefully first. Okay. So in this question, we have in a lottery, a person chooses 6 different natural numbers at random from 1 to 20. So someone had chosen 6 different natural numbers at random from 20 numbers. Okay. And if these 6 numbers match with the 6 numbers already fixed by the lottery committee, okay, then he wins the prize. So a person chooses 6 different natural numbers from 1 to 20, okay, and if these 6 numbers match with the 6 numbers which is already fixed by the lottery committee, then that person will win the prize. Okay, so what is the probability of winning the prize in the game? So we have to find here the probability of winning the prize in the game. And note this point here, order of the numbers is not important. Okay, so the order of the numbers is not matter in this question. So students, first of all, try it yourself. So you have 40 seconds to try to solve this question, and then we will provide the solution. Okay students, I hope you try to solve this question. So now we will solve this question. So what we have to do here, we have to find the probability of winning the prize in the game. Okay, so total number of ways in which one can choose the 6 different numbers from 1 to 20. So what is the total number of ways in which a person can choose 6 different numbers from 1 to 20? So that is 26. Okay, so total number of ways a person can choose 6 different natural numbers at random from 1 to 20 is 20c6. Okay, and you all know how to calculate 20c6. Okay, so you all know combination of r numbers from n numbers, that is ncr. Okay, and you all know the formula ncr, that is n factorial divided over r factorial into n minus r factorial. Okay, so if we use this formula, then you can easily calculate 20c6. Okay, so 20c6, this is equal to 20 factorial divided over 6 factorial times 20 minus 6 factorial. Okay, and after simplifying, you will get this is equal to 20 factorial divided over 6 factorial into 14 factorial. Clear? And now you can write 20 factorial as 20 into 19 into 18 into 17 into 16 into 15 into 14 factorial. Okay, and here you can see 14 factorial will be cancelled out. Okay, and it will become 20 times 19 into 18 into 17 into 16 into 15. Clear? And you can write 6 factorial as 1 into 2 into 3 into 4 into 5 into 6. Clear? And now easily uh, you can calculate, okay, by cancelling the terms. So if we calculate it, then you will get this is equal to 38,760. Okay, so total number of ways in which one can choose 6 different numbers from 1 to 20 is 38,760. Okay, and now hence there are 38,760 combinations of 6 numbers. Okay, so a person can choose 6 different natural numbers at random from 1 to 20 in 26 ways, that is 38,760 ways. Clear? And out of these combinations, one combination is already fixed by the lottery committee. Okay, and in this question we have given if these 6 numbers match with the 6 numbers already fixed by the lottery committee, then he wins the prize. Okay, and we have to find here the probability of winning the prize in the game. Okay, so out of these combinations, one combination is already fixed by the lottery committee. So what will be the probability of winning the prize in the game? So therefore required probability of winning the prize in the game is 1 over 38,760. Clear? So our answer will be 1 upon 38,760. Okay, and this is the required probability of winning the prize in the game. So students, I hope it is clear to all of you. Okay, so now let us move to the next question. Now look at question number 12. So in this question we have to check whether the following probabilities P of A and P of B are consistently defined. So you have to know what does mean consistently defined. Okay, then you can check whether the following probabilities P of A and P of B are consistently defined. Okay, so we have given here probability of A is 0.5 and probability of B is 0.7. Okay, and probability of A intersection B is given to us 0.6. Okay, and we have to check here whether the following probabilities P of A and P of B are consistently defined. Okay, so first check first one and then check second one. In second one we have given data P of A is 0.5, P of B is 0.4 and P of A union B is 0.8. Clear? So students, first of all try to solve this question. Okay, so check whether the following probabilities are consistently defined. Okay, so try it yourself first. So you have 40 seconds to try to solve this question and then we will provide the solution. Okay, now we will check whether the following probabilities P of A and P of B are consistently defined. Okay, so first see one. Okay, first one. So in first one we have given probability of A is 0.5, probability of B is 0.7 and probability of A intersection B is 0.6. Okay, and it is known that if E and F are two events and such that E subset F, then probability of E is less than equal to probability of A. Okay, and this is how we can check whether the following probabilities P of A and P of B are consistently defined. Okay, so here you can see probability of A is given to us 0.5. Okay, and probability of A intersection B is given to us 0.6. Clear? So you can easily check here probability of A is less than probability of A intersection B, but you all know A intersection B is subset of A. Okay, so A intersection B is subset of A, but P of A is less than P of A intersection B. That means here A and B are two events such that A and A intersection with B two events. Okay, and here A is proper subset of A intersection B. Okay, A is super subset of A intersection B. That means A intersection B is subset of A. So it should be followed. Probability of A intersection B is less than equal to probability of A. But we have here P of A intersection B is greater than P of A. Clear? So P of A and P of B are not consistently defined. Clear? So P of A and P of B, these two probabilities are not consistently defined. I hope it is clear. So now we will check second one. So in second one, here we have given probability of A is 0.5 and probability of B is 0.4. Okay, and we have given probability of A union B is 0.8. Clear? So now we can see here, first note here, it is known that if E and F are two events such that E subset F, then probability of E is less than equal to probability of F. Okay, and here it is seen that probability of A union B is greater than probability of A. Okay, and also A union B is A is subset of A union B. Okay, so it follows A subset A union B, it implies probability of A less than probability of A union B. Okay, and also probability of A union B is greater than probability of B. Okay, so hence P of A and P of B are consistently defined. Okay, so for second case, for second one, probability of A and probability of B are consistently defined. Clear? So I hope it is clear to all of you. So this is very simple. Just here you should know, you should remember this thing. If E and F are two events such that E subset F, then P of E less than equal to P of F. Okay, so note this point. This point is very important point. Clear? So now we will see next question. So look at question number 13. So here we have to fill in the blanks in the following table. So in this table we have missing some value of some numbers. Okay, so here you can see P of A we have given, and all the values of P of A are given in the three problems. And then in second one, P of B, so here you can see second one here, one place is blank, so we have to fill this blank. And then in third, P of A intersection B, so here this place is blank. Okay, so we have to fill this place. And then here you can see P of A union B, this place is blank. Okay, so we have to fill this blank. So simply you can use this formula, P of A union B equal to P of A plus P of B minus P of A intersection B. Okay, so use this formula and then try to calculate the missing values. Okay, clear? So first of all, try it yourself. You have 40 seconds to try to solve this question, and then we will provide the solution. Okay, students, now we will solve this question. So here P of A, that means probability of A is given to us 1 by 3. Okay, so look at first one first. Okay, so probability of A is given to us 1 by 3, probability of B is 1 by 5, and probability of A intersection B is 1 by 15. Okay, so now we have to find probability of A union B. So we will know that probability of A union B, this is equal to probability of A plus probability of B minus probability of A intersection B. Okay, so you should remember this formula. So keep in your mind this formula. Okay, and we are applying this formula and we will find probability of A union B. So now put the values of probability of A is 1 by 3, probability of B is 1 by 5, and probability of A intersection B is 1 by 15 in this formula. Okay, then we will obtain probability of A union B. This is equal to 1 by 3 plus 1 by 5 minus 1 by 15. Okay, so now take LCM of 3, 5 and 15. So you will get LCM 15. Okay, and this is equal to 5 plus 3 minus 1 divided over 15. Okay, and after simplifying, you will get probability of A union B. This is equal to 7 over 15. Okay, so in place of this missing place, here it should be 7 over 15. Okay, now here in second one, we have given probability of A is 0.35. Okay, and probability of A intersection B is given to us 0.25, and probability of A union B is given to us 0.6, and here one number is missing in place of probability of B. So we have to find here probability of B. Okay, so how can we find probability of B? So we will know that probability of A union B, this is equal to probability of A plus probability of B minus probability of A intersection B. Okay, so this formula is very crucial formula. Okay, so you should keep in your mind this formula. So by using this formula, we can find probability of B. Okay, just put the values of probability of A equal to 0.35, probability of A intersection B is 0.25, and probability of A union B equal to 0.6. Then we will obtain this equation, that is 0.6 equal to 0.35 plus probability of B minus 0.25. Okay, and now it implies probability of B, this is equal to 0.6 minus 0.35 plus 0.25. Okay, so now calculate this. Okay, and you will get probability of B. So probability of B, this is equal to 0.5. So we obtain here probability of B is 0.5. So in the blank space, okay, in place of probability of B in second one, here it should be 0.5. Clear? Now here in third one, you can see here probability of A is given to us 0.5. Okay, and probability of B is 0.35, and probability of A intersection B is 0.7, and we have to find here probability of A intersection B. Okay, so similarly we can use the same formula. So that formula we will know that probability of A union B, this is equal to probability of A plus probability of B minus probability of A intersection B. Okay, so using this formula and find the value of A, probability of A, find the value of probability of A intersection B. Okay, here it should be probability of A union B. Okay, so we have given here probability of A union B is 0.7. Okay, and we have to find here probability of A intersection B. So now just put the values of probability of A is 0.5, probability of B is 0.35, and probability of A union B equal to 0.7. Okay, and then you will get this equation 0.7 equal to 0.5 plus 0.35 minus probability of A intersection B. Okay, and it implies probability of A intersection B. This is equal to 0.5 plus 0.35 minus 0.7. Okay, just we move probability of A intersection B into left hand side. Okay, and the numbers move to the other side. Then we obtain this equation probability of A intersection B. This is equal to 0.5 plus 0.35 minus 0.7. Okay, now calculate it. So after calculating, we will obtain probability of A intersection B is equal to 0.15. Clear? So in place of probability of A intersection B in third one, here it should be 0.15. So we found the values of probability of A union B in first one. In second one, we found probability of B, and in third one, we found the value of probability of A intersection B. Okay, and we filled the blanks. Clear? So I hope it is clear to you. So now let us move to the next question. So first read the question very carefully, okay, and try to understand what you have to find. Okay, and what you have given, see that first. So given in this question, probability of A is 3 over 5 and probability of B is 1 by 5. Clear? And you have to find probability of A or B if A and B are mutually exclusive events. So what does mean mutually exclusive events? So we have already studied about mutually exclusive events. So if A and B are mutually exclusive events, then the intersection of the event A and B should be empty set. Okay, that is A intersection B is empty. Then A and B are called mutually exclusive events. Okay, so this is given to us. If A and B are mutually exclusive events, then what is the probability of A or B? And we have given probability of A is 3 over 5 and probability of B is 1 over 5. So students, try it yourself first. So you have 40 seconds to try to solve this question, and then we will provide the solution. Okay, your time is over. So now we will solve this question. So here we have given probability of A is 3 over 5 and probability of B is 1 over 5. Okay, and we have given this information A and B are mutually exclusive events, and we have to find probability of A or B. So for mutually exclusive events A and B, probability of A of B, this is equal to directly probability of A plus probability of B. Okay, so in general probability of A or B does not equal to probability of A plus probability of B. But if A and B are mutually exclusive events, then probability of A or B, this is equal to probability of A plus probability of B. Why? Because A intersection B is empty. Okay, and probability of A intersection B is 0. Okay, so if we now put the value of probability of A intersection B equal to 0 in the formula, probability of A or B equal to probability of A plus probability of B minus probability of A intersection B, then you will obtain this formula, probability of A of B equal to probability of A plus probability of B. Okay, So now just put the values of probability of A is 3 over 5 and probability of B is 1 over 5. Okay. So then you will obtain the value of probability of A or B. Clear? So probability of A or B, this is equal to 3 over 5 plus 1 over 5. Okay, now calculate it. Then you will get 4 over 5. Okay. So therefore probability of A or B, this is equal to 4 over 5. Clear? So probability of A or B, this is equal to 4 over 5. I hope it is clear to all of you. Now let us move to the next question. So read the question very carefully, okay, and then answer the question. So in this question we have given if E and F are events such that probability of E is given 1 over 4, probability of F is given 1 over 2, okay, and probability of E and F is given 1 by 8. And then we have to find first probability of A of F, okay, and secondly we have to find probability of not E and not F. Clear? So students, first of all try it yourself. So you have 40 seconds to try to solve this question and then we will provide the solution. Okay students, now we will solve this question. So in this question what we have given, okay, so E and F are events and we have given probability of E is 1 by 4 and probability of F is 1 by 2 and probability of E and F is 1 by 8. Then we have to find probability of E or F, okay, and then we have to find probability of not E and not F. Clear? So here we have given probability of E is 1 by 4 and probability of F is 1 by 2 and probability of E and F is 1 by 8. Okay. So which formula you can use to find probability of E or F? So we know that probability of E or F, this is equal to probability of E plus probability of F minus probability of E and F. Okay, so you can rewrite this formula as probability of E union F equal to probability of E plus probability of F minus probability of E intersection F. Okay, so using this formula we can find probability of E or F. Clear? So just put the given values. Probability of E is 1 by 4, probability of F is 1 by 2 and probability of E and F is 1 by 8. Okay, then you will obtain probability of E or F, this is equal to 1 by 4 plus 1 by 2 minus 1 by 8. Okay, now simplify it, then you will obtain this is equal to 5 by 8. Okay, so probability of E or F, this is equal to 5 by 8. So now from 1 we obtain probability of E or F, that is probability of E union F is 5 by 8. Okay, so we note here this value because we will use this value for finding probability of not E and not F. Clear? So we have De Morgan's law. Okay, so you all know De Morgan's law, that is E union F whole complement equal to E complement intersection F complement. Okay, so you all know this law. Okay, and if you don't know then you you should keep in your mind this law. This is very important law. Okay, in one set. So E union F whole complement equal to E complement intersection F complement. So now therefore probability of E complement intersection F complement, this is nothing but equal to probability of E union F complement. Okay, E union F whole complement probability of. Okay, and we will know probability of E union F whole complement, this is equal to basically 1 minus probability of E union F. Okay, so we have studied how to find probability of complement of event. Okay, so if we have event A and we have given probability of A, okay, some value, and then we have to find probability of A complement. So that case you should use this formula, probability of A complement equal to 1 minus probability of A. Okay, so here you can see probability of E union F complement, this is equal to 1 minus probability of E union F. Okay, and already we know probability of E union F is equal to 5 by 8. Okay, just use this value of probability of E union F, and then you will obtain probability of E union F whole complement, this is equal to 1 minus 5 by 8. Okay, and this is equal to 3 by 8. So probability of E union F whole complement, this is equal to 3 by 8. Okay, simply we use here this formula. Okay, and we put the value of probability of E union F equal to 5 by 8, and we obtain probability of E union F whole complement, this is equal to 3 by 8. Clear? And we already know probability of E complement intersection F complement, this is equal to probability of E union F whole complement, and we found here probability of E union F whole complement, this is equal to 3 by 8. Okay, so therefore probability of E complement intersection F complement, this is equal to 3 by 8. Clear? So since we know this, so probability of A complement intersection F complement, this is equal to 3 by 8. Thus probability of not E and not F. Okay, E complement means not E and F complement means not F. Okay, and intersection mean and. Okay, so probability of not E and not F, this is equal to 3 by 8. Clear? So we found probability of E or F, that is 5 by 8, and by using this, okay, and by using De Morgan's law, okay, we obtain this equation. Okay, and from this equation we found probability of E union F whole complement is 3 by 8. Okay, and this is nothing but equal to probability of E complement intersection F complement. So we obtain the value of probability of E complement intersection F complement is 3 by 8. Okay, and this is actually probability of not E and not F. Clear? So I hope it is clear to you. So now let us move to the next question. So read the question very carefully first. So we have given events E and F are such that probability of not E or not F is 0.25. Then state whether E and F are mutually exclusive. Okay, so we have to check here E and F are mutually exclusive or not. Okay, and we have given this condition, probability of not E or not F is equal to 0.25. So students, first of all, try it yourself. So you have 40 seconds to try to solve this question, and then we will provide the solution. Okay students, now we will solve this question. So we have to check whether E and F are mutually exclusive. So it is given that probability of not E or not F is 0.25. Okay, so note this point. And that is probability of E complement union F complement is 0.25. Okay, so this means probability of not E or not F, this means probability of E complement union F complement. Okay, and now we will know De Morgan's law. Okay, that is E intersection F whole complement equal to E complement union F complement. Okay, and from there we will obtain probability of E complement union F complement equal to probability of E intersection F whole complement. Okay, and here we have probability of E complement union F complement is 0.25. Okay, and if probability of E complement union F complement is equal to probability of E intersection F whole complement, so probability of E intersection F whole complement, this is also equal to 0.25. Okay, since note this here, E complement union F complement, this is equal to E intersection F whole complement. Okay, and now probability of E intersection F, this is nothing but equal to 1 minus probability of E intersection F whole complement. Okay, so basically we write, okay, we will know probability of E intersection F whole complement, this is equal to 1 minus probability of E intersection F. Okay, and just we here we have given probability of E intersection F whole complement. Okay, and we have to find probability of E intersection F. Okay, so probability of E intersection F, this is equal to 1 minus probability of E intersection F whole complement. Now put the value of probability of E intersection F whole complement equal to 0.25 in this formula. Okay, and then we will obtain probability of E intersection F, this is equal to 1 minus 0.25. Clear? And it implies probability of E intersection F, this is equal to 0.75. Okay, 1 minus 0.25, this is equal to 0.75. So we obtain here probability of E intersection F is 0.75, and probability of E intersection F does not equal to 0. Okay, 0.75 does not equal to 0. So probability of E intersection F does not equal to 0. And it implies E intersection F not equal to empty set. Okay, so E intersection F not equal to empty because probability of E intersection F not equal to 0. Clear? So thus E and F are not mutually exclusive. Okay, why? Because we will know if E and F are mutually exclusive, then E intersection F is should be empty set. Okay, and from there we will obtain probability of E intersection F is 0. Okay, but here we get probability of E intersection F is not equal to 0. Okay, and it implies E intersection F does not equal to 5. Okay, and so E and F are not mutually exclusive events. Clear? So I hope it is clear to all of you, and this question is very simple question. So now let us move to the next question. So now look at question number 70. Okay, so first of all read the question very carefully, okay, and then answer the question. So we have A and B are events such that probability of A is 0.42, probability of B is 0.48, and probability of A and B is 0.16. Then we have to determine probability of not A, okay, and probability of not B, and probability of A of B. Okay, so we have given probability of A is 0.42, probability of B is 0.48, and probability of A and B equal to 0.16. Okay, then you have to find probability of not A, probability of not B, and probability of A of B. Clear? So students, first of all try yourself. So you have 40 seconds to try to solve this question, and then we will provide the solution. Okay, students, now we will solve this question. So what we have given here? So we have given here probability of A is 0.42, probability of B is 0.48, and probability of A and B equal to 0.16. Okay, and then probability of not A, this is equal to 1 minus probability of A. Okay, so this is our formula. So note this formula, and using this formula we will find probability of not A. This is equal to 1 minus probability of A, and we have given here probability of A is 0.42. So now put the value of probability of A is 0.42 in this formula, then we will obtain probability of not A. This is equal to 1 minus 0.42, and this is equal to 0.58. Okay, so probability of not A, this is equal to 0.58. Now probability of not B. So probability of not B, this is nothing but equal to 1 minus probability of B. Okay, and we have given probability of B is 0.48. Okay, so now put the value of probability of B is 0.48, then we will obtain probability of not B. This is equal to 1 minus 0.48. Okay, and this is equal to 0.52. So probability of not B, this is equal to 0.52. Now we know that probability of A or B, this is equal to probability of A plus probability of B minus probability of A and B. Okay, and this formula you can also write as probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. Okay, so just see, we have given probability of A is 0.42, probability of B is 0.48, and probability of A and B is 0.16. Okay, so put these values in this formula, then we will obtain probability of A or B. This is equal to 0.42 plus 0.48 minus 0.16. Okay, so now calculate it. So you will get this is equal to 0.74. Okay, so probability of A or B, this is equal to 0.74. So I hope it is clear to all of you. So now let us move to the next question. So read the question very carefully first. Okay, so in this question we have, in class 11 of a school, 40% of the students study mathematics and 30% study biology, and 10% of the class study both mathematics and biology. So if a student is selected at random from the class, then find the probability that he will be studying mathematics or biology. Okay, so we have given some information. Okay, so first note the information here. So number of students of a class in a class 11 of a school is 40% of mathematics. Okay, 30% study biology, 10% study both mathematics and biology. Okay, and then you have to find probability of studying mathematics or biology. So first of all, try it yourself. So you have 40 seconds to try to solve this question, and then we will provide the solution. Okay, students, now we will solve this question. So first let A be the event in which the selected student studies mathematics, okay, and B be the event in which the selected student studies biology. Okay, so we let here first event A, that is denoted the selected student studies mathematics, and the event B, that is denoted here the selected student studies biology. So accordingly, probability of A is 40%, that is 40 over 100. Okay, and after simplifying, you will get this is equal to 2 over 5. Okay, so probability of A is 2 over 5. And then probability of B is 30%. This is equal to 30 over 100, and this is equal to 3 by 10. Okay, so probability of B is 3 over 10. And then we have given probability of A and B. Okay, that means the student who studies mathematics and biology both. Okay, so probability of A and B, this is your 10%, and this is your 10 over 100 equal to 1 by 10. And we know that probability of A or B, this is equal to probability of A plus probability of B minus probability of A and B. Okay, so just put the values of probability of A, probability of B, and probability of A and B. Okay, then probability of A and B, then you will obtain the value of probability of A or B. So therefore probability of A or B, this is equal to 2 over 5 plus 3 over 10 minus 1 over 10. Okay, and after simplifying, you will get this is equal to 6 over 10, and this is equal to 0.6. So probability of A or B, this is equal to 0.6. Okay, and this means probability that he will be studying mathematics or biology is 0.6. Okay, thus the probability that the selected student will be studying mathematics or biology is 0.6. Clear? So I hope it is clear to all of you. Now let us move to the next question. So in an entrance test that is graded on the basis of 2 examinations, so the probability of a randomly chosen student passing the first examination is 0.8, and the probability of passing the second examination is 0.7, and the probability of passing at least one of them is 0.95. So what is the probability of passing both? Okay, so students, first of all, try it yourself. So you have 40 seconds to try to solve this question, and then we will provide the solution. Okay students, now we will solve this question. First, let A and B be the events of passing first and second examinations respectively. Okay, so A is the event of passing first examination and B is the event of passing second examination. And now accordingly, probability of A is given 0.8, probability of B is given 0.7, and probability of A or B is given 0.95. Okay, and we know that probability of A or B equal to probability of A plus probability of B minus probability of A and B. Okay, so now just substitute the values of known values. Okay, that is probability of A equal to 0.8, probability of B is 0.7, and probability of A or B equal to 0.95. Okay, so after putting the values of P of A, P of B, and P of A or B, we will obtain probability of A and B. Okay, so it implies probability of A and B, this is equal to 0.8 plus 0.7 minus 0.95. Okay, and this is nothing but equal to 0.55. So probability of A and B, this is equal to 0.55. So thus the probability of passing both the examination is 0.55. Okay, So this is our answer. So our answer will be 0.55. So I hope it is clear to all of you. So now let us move to the next question. So read the question very carefully. So in this question, we have the probability that a student will pass the final examination in both English and Hindi is 0.5, and the probability of passing neither is 0.1. So if the probability of passing the English examination is 0.75, so what is the probability of passing the Hindi examination? Okay, so what we have given, probability that a student will pass the final examination in both English and Hindi is 0.5. Okay, and probability of passing neither is 0.1, and probability of passing the English examination is 0.75. Then we have to find probability of passing the Hindi examination. So first of all, try it yourself. So you have 40 seconds to try to solve this question, and then we will provide the solution. Okay, students, now we will solve this question. So first, let A and B be the events of passing English and Hindi examination respectively. Okay, and accordingly, probability of A and B is given 0.5. Probability of not A and not B is given 0.1. That is, probability of A complement intersection A B complement is 0.1. Okay, and probability of A is 0.75. Now we know De Morgan's law, A union B whole complement is A complement intersection B complement. Okay, therefore probability of A union B whole complement, this is equal to probability of A complement intersection B complement. Okay, and we have here probability of A complement intersection B complement is 0.1. So probability of A union B whole complement, this is also equal to 0.1. Okay, and we know that probability of A union B, this is equal to 1 minus probability of A union B whole complement. Okay, and we've already found probability of A union B whole complement, this is equal to 0.1. So now put these values, and then we will obtain probability of A union B, this is equal to 1 minus 0.1. Okay, and this is equal to 0.9. So probability of A union B, this is equal to 0.9. And we know that probability of A or B, this is equal to probability of A plus probability of B minus probability of A and B. Okay, so now put the values of probability of A or B and probability of A and probability of A and B. Then we will obtain this equation 0.9. This is equal to 0.75 plus probability of B minus 0.5. Okay, and from here we will obtain the value of probability of B. So probability of B, this is equal to 0.9 minus 0.75 plus 0.5. Okay, so now calculate it. So you will obtain probability of B, this is equal to 0.65. So thus the probability of passing the Hindi examination is 0.65. Okay, so our answer will be 0.65. So I hope it is clear to you. So now let us move to the next question. So read the question very carefully first. Okay, so in this question we have, in a class of 60 students, 30 opted for NCC, 32 opted for NSS, okay, and 24 opted for both NCC and NSS. If one of these students is selected at random, then find the probability that the student opted for NCC or NSS. And the second one, the student has opted neither NCC nor NSS. Okay, and the third one, the student has opted NSS but not NCC. Okay, so students, first of all, try it yourself. So you have 40 seconds to try to solve this question, and then we will provide the solution. Okay, students, now we will solve this question. So first, let A be the event in which the selected student has opted for NCC. Okay, and B be the event in which the selected student has opted for NSS. Clear? So first, let the events. And then here you can see total number of students is 60. Clear? Number of students who have opted for NCC is 30. So therefore probability of A is 30 upon 60. Okay, and this is equal to 1 by 2. So probability of A is 1 by 2. And number of students who have opted for NSS is 32. Okay. And therefore probability of B is 32 over 60. Because there are total number of students 60. Okay, out of 60, there 32 students opted for NSS. Clear? So probability of B is 32 over 60 is 8 over 15. So number of students who have opted both NCC and NSS is 24. So probability of A and B is 24 over 60. This is equal to 2 over 5. And we know that this formula, probability of A or B, this is equal to probability of A plus probability of B minus probability of A and B. Okay. So probability of A or B, this is equal to 1 by 2 plus 8 over 15 minus 2 over 5. So basically we have we put the values of probability of A, probability of B and probability of A and B. Okay, and we obtain probability of A or B. This is equal to 1 over 2 plus 8 over 15 minus 2 over 5. Now simplify it, then you will obtain 19 over 30. So probability of A or B, this is equal to 19 over 30. So that's the probability that the selected student has opted for NCC or NSS is 19 over 30. Okay, so the answer of first one will be 19 over 30. Now, probability of not A and not B. Okay, this is nothing but probability of A complement and B complement. Clear? And this is nothing but equal to probability of A complement intersection B complement. And this is equal to probability of A union B whole complement. Okay, note this formula. A complement intersection B complement equal to A union B whole complement. This is basically our De Morgan's law. Okay. And then probability of not A and not B, this is equal to 1 minus probability of A union B. Why? Because probability of A union B whole complement, this is nothing but equal to 1 minus probability of A union B. Okay. So probability of not A and not B, this is equal to 1 minus probability of A union B. And this is equal to 1 minus probability of A or B. Now put the value of probability of A or B, this is 19 over 30. So probability of not A and not B, this is equal to 1 minus 19 over 30. Okay, and this is equal to 11 by 30. So thus the probability that the selected students has neither NCC nor NSS is 11 by 30. Okay, so the student has the probability of that the student has opted neither NCC nor NSS will be 11 by 30. The given information can be represented by Venn diagram as, so you can write okay the given information by using Venn diagram, okay, like this. So then here you can see A event contains 30, okay, 30 elements. B event contains 32 elements, and in intersection we have 24. So it is clear that number of students who have opted for NSS but not NCC is number of element in B difference A. Okay, and this is nothing but equal to number of element in B minus number of element in A intersection B. Okay, and this is equal to 32 minus 24 equal to 8. Thus the probability that the selected students has opted for NSS but not NCC is 8 over 60. Clear? And now simplify it, then you will obtain 2 over 15. So the probability that the student has opted NSS but not NCC is 2 over 15. So I hope it is clear to all of you. So that's all for today's lecture. So thank you very much to all of you.